Welcome to 3.3 Part 5. I'm Gregory Carlson. We're going to FOIL this right now. Let's do it. Let's just start by FOILing these two. X times x is, I'm just going to scratch that out. X times x is x squared. X times negative 1 is negative x. X times negative root 5 is negative x root 5. So far, so good. Negative 1 times x is negative x. Negative 1 times negative 1 is plus 1. Negative 1 times negative root 5 is plus root 5. Here we go. Root 5 times x is x root 5. Root 5 times negative 1 is negative root 5. And 5 times negative root 5, well, that times that is just 5. And so it's going to be minus 5. So that was a lot, but you're going to see a lot of stuff will cancel in here, so that's nice. All right, let's do the FOILing of these two now. It's kind of similar. X times x is x squared. X times negative 7 is negative 7x. X times negative I is negative ix. Next part, negative 7 times x is minus 7x. Negative 7 times negative 7 is plus 49. Negative 7 times negative I is plus 7i. And now let's do the I. I times x is ix. I times negative 7 is negative 7i. I times negative I is negative I squared. All right, something really special is going to happen with the canceling of this as well. So let's simplify this a bit. I have negative x root 5 canceling with x root 5. Also, I have root 5 canceling with negative root 5. So that's kind of nice. So this simplifies to x squared. Those combine to negative 2x. And 1 minus 5 is negative 4. So I get x squared minus 2x minus 4. Over here, negative ix cancels with ix. 7i cancels with negative 7i. Don't forget, minus I squared is negative 1, so that's plus 1 right there. Minus I squared is the same as plus 1. So this is going to be x squared minus 7x plus 50. So there you go. Notice, oh dear, my notes say, oh, I left out a term. Oh, I'm sorry, negative 7x minus 7x, that should be minus 14x. Sorry about that. So we have minus 14x right there. I missed a term. Okay. Notice that when we multiply a conjugate times its conjugate, all of the i's fall out. That should always happen. So if the i's don't all cancel, you made a mistake somewhere with your multiplying. But all of the i's should cancel out. Let's do a FOIL one more time just to get the final polynomial. So x squared times x squared is x to the 4th minus 14x squared plus, actually that should be x to the 3, sorry. X squared times negative 14x should be negative 14x to the 3. And then plus 50x squared. Okay, we've done that one. Minus 2x to the 3 plus 28x squared minus 100x, right? So, okay, so minus 2x to the 3 plus 28x squared. Yep, that's good. And then minus 4x squared plus 14 times 4, I think is 42. Oops. 14 times 4 is 56. So negative, that'll be plus 56x. Then negative 4 times 5 is minus 200. All right, so let's simplify one last time. We have x to the 4 will not combine with anything. I have negative 14x to the 3, negative 2x to the 3. So that'll be negative 16x to the 3. How about x squared? There's 50 and 28 is 78. Minus 4 is 74. So plus 74x squared. Negative 100 plus 56 is minus 44x minus 200. There's your polynomial. If you can do that one, you can do pretty much anything, because that's about as hard as they come. Let's really quickly talk about what we just found. We see that this polynomial has degree of 4, which means it has 4 roots, including multiplicity, thanks to the fundamental theorem of algebra. Those roots are 1 minus root 5, 1 plus root 5, 7 minus I, and 7 plus I. If you plugged in any one of these 4 numbers into this polynomial, then that means that you're going to get 0, including if you plug in like 7 minus I. All of the i's are going to cancel or turn into I squareds and become negative 1s, and they're all going to cancel with each other. Everything's going to end up being 0. So I know that was a lot of simplification. However, this is college algebra, and you're getting up there in math, and that's good. We're making steps. By the way, you'll notice that in a way, polynomials are kind of defined by what their zeros are. And if you have a unique sequence of zeros, of different numbers that make a polynomial equal 0, that's going to give you a unique polynomial. So that's something kind of interesting to think about. We have one more problem to do. We have a polynomial of degree 5. Of degree 5! And we're going to find the roots of this polynomial. And we are going to do that in part 6. So I will see you there.